Hello, good morning, good afternoon, good evening, depending on where you are watching me from. How are you guys doing? I hope you are doing very okay. I wish you a wonderful day or a wonderful bed rest. Yeah, in this video, we'll be looking at simultaneous linear first order differential equations. We are going to solve one simple example. It's not difficult. But before we solve this example, let's just pray to our God for more understanding and retentive memory so that anything we are going to learn here will not forget. Is that clear? So please, we are in prayer for 2 seconds. Amen. Yeah, right. If today is your first time of meeting me here, go to Google and type Remjock Maths, amen. It will do you good. Remjock Maths. You will see a lot of solved mathematical problems and solutions. Not only that, you will also see comprehensive mathematics lecture notes for both those people who are preparing for NECO, WAEC, GC, JAM, ND, HND, BSc, Masters, up to PhD level. You will see solved problems, mathematical problems, and solutions, comprehensive mathematics lecture notes. It will do you good. Testimony have been coming. People have been thanking me for my good work. Please don't forget, make sure you share this video and also share everything. This Remjock Maths. Not only that, you can also meet me on Facebook, TikTok. Just type Remjock Maths. You will see Mr. OSI. Yeah, you will see Mr. OSI. You will see Mr. OSI. Although, yeah. So subscribe to my YouTube channel. Follow me on Facebook, TikTok, so that you will learn and understand mathematics very well. It's okay. Yeah, so let's look at this one as initial condition. I think the first one we solved, there was no initial condition. So let's write solution, amen. Solution, our x prime minus 2x plus y equals to 0. Our initial condition, x of x is equals to 1. We name this one equation 1. Then y, y prime minus y plus x is equals to 10. Amen. Then y of 0 is equals to 0. Then this is equation 2. Yeah. It's not difficult. Let me open your eyes. We call this initial value conditions. This is the same thing as x of, I told you now. I told you x of t. So if we have x of 0 equals to 1, it means your t is 0. That is why this place is 0. Please take note. While your x is equals to 1. Are you following? But if we have y, this is y of t, but you know that here we have 0, y of 0 equals to 0. It means here your t is equals to 0. Also your y too is what? 0. Are you following? Take note. It's very important. So whenever you come across something of this form, I told you that this simultaneous linear equation, differential equation, has to do with what? Time. We are talking about the time. Is that clear? So you are differentiating this first order derivative has to do with dx all over dt. You know, I told you in the other video that if sometimes they can set it this way, bring it this way. Look at it. Now here we have 2x plus y. So if we want to transform it, since it is simultaneous equation, we can now transform it this way to t. Or this is the same thing as d operator x dx. True or false? If you remember, I told you that this is the same thing as d operator. So since we have x here, you use the x to multiply this, so it's going to give you dx. So you have to take note of all this. Is that clear? Now let's solve this idiot. As simple as ABC. Amen. Okay. So we have to recall this. Yeah. Amen. Okay. If you can see what to make this solving easier for you and I. In equation 1, make y the subject of the formula. If you can see what I am saying. Amen. If you make y the subject of the formula, from equation 1, make from equation 1, make y the subject of the formula, or the subject. If we make y the subject, it means y will now be equals to, this one crosses the sign of equality becomes what? Plus, so 2x, then this y, x prime crosses the sign of equality becomes minus x prime. We assume this one to be equation 3. Do you agree with me? Okay? Then, at this point, what we are going to do here is for us to differentiate this equation implicitly with respect to what? X. Differentiating equation so that we'll be able to substitute it into equation 2. Since equation 2 has y prime, then what we will do here is differentiating equation 3. Equation 3. I hope you are following. So if we differentiate, you know how to differentiate equation, this implicit function, true or false. So let me just show you. I know some of you might have forgotten your elementary calculus. If you have something of this form, 2x minus x prime, apply this all over dx equals to d all over dx. Amen. Okay, since we are dealing with time, t, yes, minus all over x prime. So if you come across something of this form, if you want to implicitly differentiate this, this means d all over dt means differentiate what is inside the bracket. So if you differentiate it, you are going to have dy all over dt. If you differentiate y is 1, isn't it? 1 times dy is the same thing as 1. Why are we writing y? Because you differentiated for what? For y. That is why you are seeing y. So now the right answer will now be the same thing. If you differentiate 2x, you are going to have what? 2. So here will be 2 dx all over what? dt. Then, sorry, minus differentiate x prime. We are going to have d square x all over dt square. This is what you are going to have. So take notes in case you come across something of this one. Okay, so let us look at it together. Amen. Let's look at it together. So here we're going to give us, since we are dealing with prime, here will now be y prime is equals to 2x prime, then minus x prime prime. This is equation 4. Yeah. So at this point, what we need to do here is for us to substitute equation 3 and 4 into equation 2, if you can see what I am saying. So we now write substituting, amen, equation 3 and 4 into equation 2. So if you agree with me, we are going to have, anywhere you see y prime, you write this. That is 2x prime minus x prime prime. Then this is minus y. Anywhere you see y, you write 2x minus y x prime. So since it is minus, put brackets, don't rush, 2x minus x prime, close the bracket. What do you have here? Plus x, then equals to what? 10. This is equation 5. Amen. Okay. Now we open this bracket. If we open this bracket, we are going to have 2x prime minus 2x prime prime minus times this is going to give us minus 2x minus times plus is going to give us plus x prime, amen, then plus x equals to 10, amen. This is equation 6. Yeah. So far so good. At this point, we now collect like terms. If you can see what I am saying, we collect like terms. 2 of us. Hope I'm right. I'm right, okay. We have this and this to this. Okay. So here will now be, you can see what I am saying. Here will be minus collect like terms minus let's write collect like terms. Amen. If we collect like terms, we are going to have minus x prime prime, then yes, plus 2x prime plus x prime, amen. Then we are going to have I think here is 0. Sorry, this place is 0. Take note. Here is 0, not 10. Here is 0, and 2 is 0. Please take note. So it's going to give us this. Okay. This and this, then minus 2x plus x is equals to 0. This is equation 7. Amen. Okay. Yeah. If you can see what I am saying now, amen. Hope we are right. We are right. Okay. So if you can see what I am saying now, we can add this to give us 3 minus x prime prime plus 3x prime, then minus what? X equals to 0. This is equation 8. Then use minus to multiply through the equation 8. Use minus to multiply through equation 8. Here will be plus. So x prime prime minus 3x prime plus x, isn't it? Equals to 0. This is equation 9. So if you can see what I am saying, we can now, amen, okay, we can now, this is second order differential equation. So we can now say that for us to obtain our M1 and M2, we now say let us use undetermined method. Let x be equals to exponential mt. So we have to differentiate it twice. X prime will now be equals to m exponential mt, and x prime prime will now be equals to, amen, m square, isn't it? Exponential mt. Because you must know how to differentiate exponential function. So you substitute this and this into this equation. So if you can see what I am saying, here will give us m square exponential mt, then minus 3m, amen. Your x prime is m exponential mt. Then your x is plus exponential mt, which is equals to 0. True or false? What is common? Exponential mt, open bracket, m square minus 3 plus 1, amen, equals to 0. So far so good. So if exponential mt not equals to 0, our m square minus 3 plus 1 equals to what? 0. Oh, sorry, this is m, sorry, 3m plus 1. This is 3m. Amen. 3m plus 1 equals to 0. Do you agree with me? I hope you are following. Okay. So this is a quadratic equation and it is called auxiliary equation. Sorry. Auxiliary equation. This is what they call an auxiliary equation. So for us to obtain our M1 and M2, you know that we cannot use factorization method to solve this quadratic equation. So we have to apply what? The formula method, which you know. Your m, since this m we want to find, your m will now be equals to minus b plus or minus square root of b square minus 4ac all over 2a. True or false? So your a is equals to 1, b is equals to minus 3, and c is equals to 1. True or false? So our m is equals to minus open bracket minus 3 plus or minus square root of minus 3 all in square minus 4 times 1 times 1, amen, all over 2 times 1. True or false? Okay, so if you can see what I am saying, yeah, if you can see what I am saying, this is minus times minus plus, so m is equals to plus 3 plus or minus, here we're going to give us 9 minus 4 times 1 minus 4 times 1 minus 4, amen, all over 2 times 1, 2. So our m will now be 3 plus or minus square root of 9 minus 4 is going to give us 5 all over 2. So note that minus is in plus or minus. Minus plus means plus or minus, amen. So our m1 will now give us 3 plus square root of 5 all over 2, amen. And our m2 will now be equals to 3 minus root 5 all over what? 2. True or false? Okay. Hope I'm right. Hope I'm very. So our general solution for this, since we are talking about x, amen, our general solution will now be our x of t will now be equals to either c1 or a exponential mt, then plus b exponential mt. Yeah. Amen. So far so good. Let me write it here. So far so good. Our so far so good. Amen. Our x of t. Amen. Our x of t, our m1, this is m1, this is m2. Our m1 is this idiot. So our x of t will now be equals to a exponential 3 plus root 5 all over 2 close bracket t, then plus b exponential, amen, exponential 3 minus root 5 all over 2 close bracket times t. That is out for x of t. Okay, how can we obtain our, amen, our x of t? We have to differentiate this. Let's call this equation 10. We have to differentiate equation 10 with respect to t. If you differentiate equation 10 with respect to t, it means you are going to have x prime of t equals to, you have a open bracket 3 plus root 5 all over 2 exponential 3 plus root 5 all over 2 close bracket t plus b open bracket 3 minus root 5 all over 2 exponential 3 minus open bracket 5 all over what? 2 close bracket t. Amen. Okay. Yeah. Differentiating equation 10, we obtain shifting equation 10. Okay, we have this. So now let's come here at, look at it, the condition. Oh, okay, we don't have okay, yeah, since we don't have prime, there is no need of differentiating it. What we need to do is let's introduce the initial condition, this to equation 10. That is note that note that our x of 0 is equals to 1. It means x is 1, so anywhere you see t is 0. True or false? So our x, which is 1, will equals to, if you this here will now be 0. 0 times this 0. Then we are going to have a exponential 0 plus here is t, right? Here is t. So 0 times this is b exponential 0. Then 1 will equals to a plus b. True or false? Yeah. This will give us a plus b. Okay. True or false? It's true. A plus b. Then, so far so good. It means we are going to substitute this, to obtain our y of t. But before we look at y of t, we are going to look at it in the next video. Please, I want you to share this video, subscribe to my YouTube channel, make sure you expect the solution to y of t in the next video. See you in the next video. Bye.